Now that we have learned what a quadratic function is, today we are going to be looking at equations of quadratic functions and how we can take those equations and put them on a graph. And just like always, be sure you watch until the end of the video so that way you can see many different types of examples and how we would solve them. So these are the steps that we follow every time we make a graph of a quadratic function. These steps, definitely keep them handy. They're on your notes page. You will definitely want to save these so you have them as a reference for later. So as I explain the steps, I'm going to show an example that I did with this quadratic function, the equation y equals 2x squared plus 4x minus 3. So the first step that we follow to graph the quadratic function is to list the values of a, b, and c. So remember, whenever we have a quadratic function, the general form is always this: y equals ax squared plus bx plus c. So in this example, the 2 is the a, positive 4 is the b, and negative 3 is the c. In step 2, check the a value to determine if there is a maximum or minimum. So in this case, if you remember from yesterday, if we have a positive x squared, that means that it is a happy graph and we'd have a minimum. Or if we have a negative x squared, that means the graph is sad and we would have a maximum. So in this case, the 2 is positive, meaning that we have a happy graph. It is a positive 2x squared, so it opens upwards, and that means we have a minimum. Step 3, use those values to find the axis of symmetry. To also, again, refresh your memory from yesterday, the axis of symmetry, it's the line that cuts right down the middle of the parabola. It's the line of symmetry, so each side of the line is the same. So we write this in the form of an equation, x equals something. And if we are not given a graph, the formula that we can use to find the axis of symmetry, because we can't see where this line would cross right now, is this right here. X equals negative b divided by 2a. This is the formula that always works, so keep this handy because you'll be using it every time to find the axis of symmetry. So in this case, the b is 4, so we want negative b, or in other words, negative 4, divided by 2 times a, or 2 times 2, since our a is 2. So negative 4 divided by 2 times 2 is 4, so x is negative 1. That is the axis of symmetry. Now, step 4, use the value of x from step 3 to substitute into the equation to find y to write the coordinates of the vertex. So we are going to use this value of x to figure out what the vertex would be. What are the coordinates of this point? We have the x, now we need the y coordinate. And so what we can do is take this x and put it back into the equation to see what y would equal in this case. So instead of x in the equation, I changed it to negative 1. Then I used order of operations to just go ahead and solve to see what this equals. So first was the exponent, then multiplication, then I added and subtracted from left to right to get y as negative 5. So I have the x and the y coordinate, so the vertex altogether is negative 1, comma negative 5. Then, step 5, use that vertex to fill in your table. So we'll have a table of values. The vertex, I put it right in the middle here, and then from the x, I put 1 above, 2 above actually, 1, 2, and then 2 below, just counting by ones, subtracting 1, adding 1 to fill in the table. Then what I do is I use these x values to figure out what y would be. So in my equation, I use the x value of negative 2. So this time I put negative 2 in for x. Again, used order of operations to solve to see that when x is negative 2, y would be negative 3. And then I did also for when x is negative 3, same thing solved to get y would be 3 in this case. So I filled in those places in the table. Then I used what I know about parabolas to figure out what these two values would be. I know that parabolas are all symmetric, meaning they're the same on one side as the other. So from the vertex, when I go back 1 on the x value and I increase by 2, that means when I go the other direction, 1 on the x, I will also increase 2 on my y. So to show you what I mean on a graph, if my vertex is at -1, -5, if I go over 1 on my x and up 2 on the y, I'm going to do the same thing on the other side of the vertex. So over 1 and up 2 on the other side. So all I need to do is, if I know that I'm adding 2 to get to here from the vertex to this point, I need to add 2 on the other side. So I would do -5 plus 2 to get -3. Then I noticed from -3 to +3 I had to add 6, so I did the same on the other side. And then the final step is to use these 5 points and put them on the graph. We know the vertex, that's the minimum point, and then we draw a parabola around it to make it have that special U shape. So I know that was a number of steps, so I'm going to walk through 1 or 2 with you so you can get an idea of how we would solve these. So the first part, we're going to fill in this part of the step here first, so just the function itself. The equation we're working with this time is y equals x squared plus 6x plus 8. So first we're going to label the a, b, and c in this function. So first the a, in this case next to the x squared, we have an invisible 1. So our a is 1, our b is +6, and the c is 8, +8. Then I look to see, is this going to be a happy face or a sad face? So in order to tell that, we need to look at this x squared. Is it a positive or negative? Well, we are multiplying it by +1. The a is positive, so it's going to be a happy face, so it will open upwards and we would have a minimum. Next, we're going to move on to the axis of symmetry. We will use this formula here to help us find the axis of symmetry. So negative, in this case our b is 6, divided by 2 times the a is 1. So then we will solve this. We'll have -6 divided by 2 times 1 is 2. So the equation for the axis of symmetry is x equals -3. Next up, I use this -3 and I put it in my equation to see what the y value would be at this vertex point. We have the x, now we need to see what the y would be. So instead of x, I'm going to put a -3 here. And now I'll use order of operations to solve. So the first thing I'm going to do is the exponent here, -3 squared. This would be -3 times -3, so this equals +9. Next up, I will do this multiplication, so +6 times -3 would be -18. And then last, we'll just add from left to right. So 9 plus -18, -9. -9 plus 8, -1. So we have the x and the y, meaning the vertex is going to be -3, -1. All right, now let's move on to the next step. So first, let's fill in the vertex here. The x is going to be -3, and the y will be -1. Then I'm going to go less and more. So I'm just counting by ones, just filling in the table here, going smaller and then bigger. And then let's start by filling in with one of these points in the equation for x. I'm going to use -4 for x. You could pick any of them though, it'll all work out the same. So in my equation, instead of x, I'll put -4. And then solve with order of operations from here. So I have this. You can write this with me on your own paper. So when x is -4, y would be 0. And then the next x value I will use is -5. So instead of x, I'll put -5. And again, solve with order of operations. So when x is -5, y is 3. Then I'm going to use the symmetry of the parabola to figure out these other two values here. So I know from the vertex, if I increase by 1 to get to the x value 1 less, my y value will also increase by 1 to get to the x value 1 more. So it's the same on both sides. Here, to get to the next point, we added 3, so we'll do the same here. This will be 3. So notice from the vertex here, it's the same on both sides, 0, 3, 0, 3. When we're counting by ones like this on the x, it's going to be the same exactly on both sides. It's symmetrical. Then the last step is to take these 5 points and to put them on the graph. So first at -5, 3. And once you have the 5 points, you connect them with the parabola shape and put arrows at the end, and that is the graph of this equation. Next up, we have the equation y equals -2x squared minus 4x plus 6. I'm going to get you started on this one. So filling in with the ABC. In this case, A is -2, B is -4, and C is +6. We need to decide if it's positive or negative. So I look, my x squared, it's being multiplied by a -2. So that means it is a sad face. So it's going to open downwards, and have a maximum. Then we need to find the axis of symmetry. So we're going to use this formula. So x equals -b, our b in this case is -4, so -4, divided by 2 times a, the a is -2. So in this case, when we have a -4, negative, it's the same as positive. So I can change this to be +4, and then 2 times -2 would be -4. So in this case, the x value, the axis of symmetry, x equals -1. All right, from here, try the rest on your own. See if you can do the rest of the process. So pause the video and do that. And once you have your answers, you can play it again to see how you did. Here's what you should have gotten for this set of work. The graph had to go a little bit above, but you could just add in the 2 lines above to get it up to the 8. But check your work, see if you got the same graph in the end as me, the same table. And of course, ask me any questions if you have any at all.